In this last video for chapter 2, we will be talking about three key concepts: the consumer's demand, the concept of elasticity, as well as income in kind. So let us begin with demand. What is the demand curve? The demand curve is simply a curve which shows the relationship between the price of X and the quantity demanded for good X. And typically, the relationship between these two factors is usually inverse. What this means is that if the price of X were to increase, the quantity demanded for good X will decrease. And this is what we call the law of demand. So if you were to plot the demand curve on a price to quantity graph, what you'll see is a downward demand curve, and this reflects the inverse relationship between price and quantity. From here, we are going to learn how to derive the demand curve using two methods. So the first method will be the mathematical method. And this is simply the demand curve expressed in the form of an algebraic equation, which is simply the price of X, which is a function of the quantity demanded, is equals to A minus B times X. The reason why the parameter in front of variable X is negative is because we want to show the inverse relationship between the price of X and the quantity demanded of X. And the parameter A is simply the maximum amount that these consumers are willing to pay for a unit of good X. That was pretty straightforward, wasn't it? I don't think it's that difficult to draw a straight line given a demand function. Well, the next method, unfortunately, is not as simple as the previous method. We're going to learn how to use graphs to draw the demand curve. And specifically, we are going to need the budget constraint as well as the indifference curves. And you will need to go back to your three best friends, the normal, inferior, as well as the given good. So to derive the demand curve using graphs, you're going to need two sets of graphs. You're going to need one regular graph with X on the horizontal axis and Y on the vertical axis, and just below it you're going to need another graph with X on the horizontal axis, and for the vertical axis you are going to label it the price of X. For the graph on top, I'm just going to establish my initial equilibrium just like how I usually do. But this time, I'm going to extend point A all the way to the bottom graph. So I'm going to label that as X0, and I know that initially the price of X is P0. So the corresponding price and quantity will give me point A on the graph below. So I'm not going to assume that the price of X is going to fall to Px1. And when the price of X falls, we know that the budget constraint is going to rotate outwards. And the next thing we have to do is to establish point C, given the Hicksian definition of real income, which is somewhere over there. And since the new budget constraint is on top of the imaginary budget constraint, I know that this individual's real income has increased. So therefore, if I move to the right side of point C, X is a normal good, and I move to the left side, X is an inferior good. And I know that beyond point A, X is a given good because the income effect will be larger than the substitution effect. And let's just say that good X is a normal good, so I've got point B. I'm going to extend this all the way down to the second graph. So I'm going to label this as X1 normal good. And given X1 normal good and Px1, I've got point B. So I'm going to assume linearity here. And what I'm going to do is I'm going to connect points A and point B so that I have a demand curve showing that X is a normal good. So this is how you typically derive a demand curve. The reason why I say assume linearity, because in real life, your demand curve is never a straight line. Sometimes it might be a curve. So I've got another point. I've got point B if let's say X is an inferior good. So same thing, I'm going to connect points A and B, and I've got a demand curve for a inferior good. And lastly, if X were to be a given good, what I have is point B over here, and I'm just going to call this X1 GG and another X1 GG. So I've got another point right here, and I can just connect points A and the new point B. So I've got an upward sloping demand curve, which shows that good X is a given good. So this is how I've derived three different demand curves, given that good X might be a inferior, normal, or given good. And we see that the demand curve for a given good is upward sloping. Is it always the case? Well, we'll find out later. Now that we've got the demand curves settled, what we need to learn next is how do we identify expenditure on good X on the demand curve. So let's say we have a demand curve and initially the price of X is P0, which gives us a quantity demanded of X0. How do we identify what is the total expenditure on good X? Well, it's very simple. Total expenditure is simply the price of X multiplied by the quantity of X, right? What that means is that if you were to calculate the area of this green triangle over here, you should get the total expenditure on good X. So what happens if the price of X falls? Well, obviously the expenditure is going to change. So if the price of X falls to P1, then the quantity demanded for good X will increase to X1. So now the expenditure is this red box over here. So if you're going to take the price of X1 multiplied by X1, you're going to get total expenditures. Therefore, the area of this box is the expenditure. Now, has expenditure increased or decreased due to the decrease in price? Well, we got to find out. And it depends on the price elasticity of demand for good X. We're going to talk about this maybe later in the video. For now, we're going to talk about how the demand curve is going to move. So we're going to talk about the dynamics of the demand curve now. Two types of dynamics would be a movement along the demand curve or a shift of the entire demand curve itself. So let's talk about the first one first. So whatever that causes a movement along the curve are endogenous factors. So what are endogenous factors? They are basically factors that are inside of the model. And in our two-dimensional model, we only have two types of factors, which is the price of X and the quantity of X. I'm going to draw the graph to show you the model. So we've got price and X and the demand curve. So you can see the only two factors are price and X. So if the price of X were to fall, then we move to the right. If the price of X were to increase, we move to the left. So what causes the demand curve to shift? Well, these are called exogenous factors. And well, I think if you use some deductive logic, exogenous would mean anything that is outside of the model. So anything that is not price nor the quantity of X. And one of these exogenous factors could possibly be the price of Y. Well, you might be wondering, what the hell does good Y have to do with this? But what if X and Y are complements? Well, maybe they are substitutes. So if they are complements and the price of Y were to increase, this, according to the law of demand, would cause the quantity demanded for Y to decrease. And because they are complements, the quantity demanded for X will decrease as well. Therefore, the demand curve for X is going to shift inwards to the left, just like this. So let's say X and Y are substitutes. So, if let's say again the price of Y were to increase, according to the law of demand, Y will decrease. And then because they are substitutes, X is going to increase, and then the demand curve for X is going to shift outwards. Just like the graph that is shown over here. One of the other exogenous factors could be maybe user preferences. Well, maybe individuals just don't like X anymore, or maybe they might like more of X. And of course, anything that is not price of X, as well as the quantity demanded for X. Well, I can think of a few. One of it could be maybe taxes or subsidies. And even a change in nominal income could actually be an exogenous factor as well. So the next thing we're going to learn for today is the concept of elasticity of demand. And unfortunately, there's more than one types of elasticity, and we'll be learning up to 3 of them today. The first and most common type of elasticity known is the price elasticity of demand. And this refers to the responsiveness of demand for good X to a change in the price of good X. And economics is a lot about equations and math. So here's the formula to find the price elasticity of demand. Basically, you're going to take the percentage change in the quantity demanded for good X divided by the percentage change in the price of good X. This can be further simplified into something else. The percentage change in Q can be written as the change in Q divided by Q, and this can be the change in P divided by P. And this can also be written in the most standard form, which is the change in Q over the change in P multiplied by P over Q. And we're going to give this equation a short form, and we're going to call it mu. And what we know about mu is that mu can take a value of between 0 and infinity. And the two vertical lines beside of mu refers to the absolute value of mu. And the reason why we want to take the absolute value is because the price elasticity of demand is always negative due to the law of demand. So we know that mu can take up a lot of values. I'm going to explain what those values mean. If mu were to take the value of 1, we say that the price elasticity of demand is unity. And as mu increases beyond 1, demand becomes more elastic. And if the value is infinity, we call this perfectly elastic. And if mu becomes lesser than 1, it becomes inelastic, and if it's 0, we call that perfectly inelastic. And what I'm going to show you next is how consumers' expenditure is going to change if there is a price change, given the different types of price elasticities. Now, different values of mu would give different types of demand curves, and this is how the demand curves should look like given the different values of mu. If mu is going to be equal to 1, this means that the change in price is going to be equal to the change in quantity. So what this means is that no matter whether price is going to increase or decrease, your expenditure is going to be the same throughout. So that's straightforward. Now, if mu is going to be infinity or demand is going to be perfectly elastic, this means that consumers are only willing to buy good X at one particular price. So if you wish to get to this point by charging a higher price, what happens is that the customers will not buy from you because they don't value it that much. If you were to price it here, well, there's no point to do that because you could have actually charged at a higher price and maximize your profits. So there should be no reason why you should lower your price. Now, if mu were to be equal to 0 or demand is perfectly inelastic, what this means is that consumers are only willing to buy one quantity of X, regardless of the price level. And when I say one quantity, it's not 1 unit of X, okay? It's a specific quantity of X. That's how much they are going to demand for. So you must be thinking to yourself, well, then that's great. Why don't I just, as a firm, increase my price so that I can increase my profits? Should I do this? Can I even do this? Well, the answer is no, because you're limited by the amount of supply you can actually give to the market. You'll learn about this more in the next few chapters. If demand is inelastic, then the change in price is going to be larger than the change in quantity. So imagine if price was initially P0 and it decreases to P1. This distance is larger than this distance. Therefore, the change in price is larger than the change in quantity. If demand was elastic, then the change in quantity is larger than the change in price. So let's say again the price of X would fall to P1, this distance is smaller than that distance. Therefore, the change in quantity is larger than the change in price. So what I can conclude from the way these demand curves are drawn is that the change in the consumer's expenditure on good X follows the direction of the larger factor. So obviously, the larger factor for inelastic demand would be price, and for elastic would be quantity. I'm now going to use some examples to show you exactly what I mean by expenditure following the direction of the larger factor. So let's say if the demand is inelastic and the price of X is going to increase, what I mean is that the expenditure on X is going to increase as well. So expenditure is also following the opposite direction of the smaller factor, which in this case is quantity. So if the price of X were to decrease, then the expenditure on X will decrease. As you can see, there's a positive relationship between price and expenditure on X. Moving on to elastic demand, if quantity demanded were to increase, then the expenditure on X would increase. And this follows the opposite direction of price since price is the smaller factor. And for a decrease in quantity, there will be a decrease in the expenditure of X. And in this case, there is a positive relationship between quantity demanded and expenditure on X. I'm going to prove why this is true later. Well, you know what? Let's just prove it now. I'm going to prove that this statement over here is true for an inelastic demand. And the first step I'm going to take is to draw a demand curve which shows an inelastic price elasticity of demand, which is steeper compared to an elastic demand. So I want the price of good X to increase, so it is going to increase from P0 to P1. And what will result is that these consumers are going to have a different level of expenditure on good X. Then label these three boxes as alpha, beta, and gamma. And gamma is actually the loss in consumer expenditure due to the increase in price. And alpha is the gain in expenditure due to the increase in price. And what we are saying is that the gain is more than the loss, so that the overall increase in expenditure will increase. Alpha plus beta, which is the new expenditure, should be more than beta plus gamma, which is the old expenditure. So I'm just going to cancel away the common terms. To find the value of alpha, which is the area of that box, I'm going to take the change in P multiplied by x1. So alpha is equals to change in P times x1. And this is more than the area of gamma, which is the change in quantity multiplied by P naught. And we know that the quantity demanded for X has fallen, therefore the change in Q is going to be a negative value. Next, I'm going to divide both sides by the change in P multiplied by X1. So the left hand side is going to simplify to a value of 1, and 1 is more than this set of algebra that you see over here. And I know that the right hand side of this equation is going to be my price elasticity of demand. So I'm just going to replace it with the value of mu, and I'm going to take the absolute value so that I don't have to bother about the negative sign. So therefore, the price elasticity of demand is less than 1. So this is inelastic. There you have it. I've proven that the relationship between price and expenditure is a positive one. Now I'm going to spend some time to prove this statement is true when the demand is an elastic one. So I'm going to do the same thing. I'm going to draw a demand curve that shows a elastic demand, and of course this is going to be much flatter than the inelastic demand. So again, I'm going to reduce the price of X so that the quantity demanded for X will increase. And after labeling out all the changes in price and quantity, I'm going to again name these three boxes as alpha, beta, and gamma. What you'll notice is that alpha is the loss in consumer expenditure, and gamma is the gain in consumer expenditure due to the fall in the price of good X. And what we're saying is that the loss is going to be smaller than the gain if this is an elastic demand. So this means that the new expenditure, which is beta plus gamma, is going to be more than the old expenditure, which is alpha plus beta. I'm going to cancel the common terms again, and gamma is simply the change in Q multiplied by P1, and this is more than the change in price multiplied by X naught. Take note of the negative sign you see there. The next thing I'm going to do is I'm going to divide this entire equation by the change in price multiplied by X naught. So what I get is this figure over here, which is more than negative 1. So therefore, mu is going to be more than 1, and I'm going to take the absolute value. The price elasticity of demand is more than 1. Therefore, this is an elastic demand, and again, I've proven that there is a positive relationship between quantity and expenditure. Okay, besides proving that I'm right about the relationship between price, quantity, as well as expenditure, we have to talk about something that's more important. How do you apply this price elasticity of demand to the budget constraint? And more specifically, I'm talking about the equation, alright? I'm talking about the budget constraint equation, not the graph. In the initial equilibrium, the budget constraint is as such. We have got nominal income, which is I naught, is equals to the expenditure on X plus the expenditure on Y. So, what if there's an economic disturbance? Say, for example, a change in the price of X. You're going to get a new budget constraint equation that looks something like this. As you can see, the quantity demanded for X and Y has changed. And this is because the consumer is going to change his bundle of X and Y to maximize his utility. So we know that nominal income has not changed. So therefore, what this means is that the right hand side of this equation must be equals to I naught, therefore it must have no change as well. So what I'm going to do now is I'm going to take the right hand side of the equation and I'm going to look at it in greater detail. So I'm going to maintain my assumption that the price of X is going to decrease. So with a decrease in the price of X, I know that according to the law of demand, quantity demand of X would have increased. Now, the thing is that will the expenditure on X increase or decrease? Well, since they're moving opposite directions, we don't know, right? So I'm just going to make a second assumption that both X and Y's are complements. Therefore, quantity demanded for Y will increase. And we know that the price of Y is fixed. So the expenditure of Y for sure is going to increase, 100%. And to make sure that there is no change in this side of the equation, we know that the total expenditure on X must decrease to offset the increasing expenditure of Y. So the question is, what is the condition required for the expenditure on X to decrease? Well, the condition is simple. The price elasticity of demand for good X has to be simply inelastic. And just like how we concluded previously, the relationship between the change in price as well as the change in expenditure is going to be a positive one for a inelastic demand, as you can see over here. So both expenditure and price are going to fall. They go in the same direction. So that is how you apply the concept of elasticity to the budget constraint equation. So that was quite easy, right? So we've got two types of elasticities to go. The next one would be the income elasticity of demand. So what is the income elasticity of demand? It is simply, again, the responsiveness of demand for good X to a change in income. And the formula we're going to use to calculate this responsiveness would be simply the percentage change in quantity demanded of good X divided by the percentage change in income, which we also know that is equal to this set of algebra that you see over here. And another way that we can express this set of algebra is also in the standard form, which is change in quantity divided by the change in income multiplied by income over quantity. And the standard form is just simply as per the subject guide. So this elasticity can take the value of less than 0, and if it's less than 0 or negative, this means that good X is either an inferior good or a given good. Remember that a given good is simply a very inferior good. And if it takes a positive value, and you guessed it, X will be a normal good. To explain this, I'm going to take the percentage change in quantity divided by the percentage change in income. Let's say the income is increased. Therefore, the percentage change in income is positive. And if quantity demanded decreased, that means X is a inferior or a given good. What if quantity demanded increases? Then good X will be a normal good, just like what we've learned in the previous videos. Let's move on to the last type of elasticity, which is the cross elasticity of demand. So what is this? It is basically the responsiveness of the demand for good X to a change in the price of good Y. You must be wondering why the hell good Y is involved again. So this responsiveness can be calculated by taking the percentage change in quantity demanded in good X divided by the percentage change in the price of Y. And this can also be expressed as this set of equations over here. And again, to express it in a very nice way, nice as according to the subject guide, we're going to write change in quantity demanded for X divided by the change in price of Y multiplied by price of Y divided by X. So what we can conclude is that if the cross elasticity of demand is more than 0 or positive, then the relationship between good X and good Y will simply be substitutes. Okay, let's just prove why this is true. I'm going to take the percentage change in quantity demanded for X divided by the percentage change in the price of Y. So let's assume that the price of Y is going to fall. According to the law of demand, the change in quantity demanded for Y is going to be a positive one. So the denominator here is going to be negative, and if the numerator is negative, there you can see that there is going to be a negative relationship between the change in quantity demanded for X and the quantity demanded for Y. Therefore, this proves that if the cross elasticity is more than 0, then they are substitutes, right? And this is because a negative number divided by a negative number is going to give you a positive number. And obviously, if the cross elasticity of demand is a negative number, then the relationship between X and Y would be complements. So taking the same assumptions, the price of Y will fall, causing an increase in demand for Y. So take a look at this numerator here. If the numerator is positive, then you have an increase in both quantity demanded for X and Y. So they are complements, right? Therefore, when you take a positive number divided by a negative number, you're going to get a negative number. Okay, congratulations! You have finished learning the demand curve, the elasticities, and now we're moving on to the last thing, which is income in kind. This is probably the last concept you're going to be learning in the series of videos for chapter 2. Alright, so income in kind is basically income in the form of an endowment. So what is an endowment? So if you're well endowed, if you're endowed, okay, so what it means is that this individual initially owns a certain amount of X and Y. We're just going to call that XE and YE to denote an endowment, right? So this means that this individual is endowed. So the question you're going to ask yourself is, then how do we calculate this income? It is basically the price of X multiplied by its initial amount of X plus the price of Y multiplied by his endowment of Y. So that is the value of his income that he initially has. So just let me show you what this should look like on the graph. There's not going to be many drastic changes. What you'll have is a standard downward sloping budget constraint. But this time, on the budget constraint, you're going to mark out point E, or the endowment point. And the endowment point is where you have XE and also YE. And since the x-intercept is going to be the amount of income divided by the price of x, I'm just going to take the entire equation that we saw previously and divide this by x. And I'm going to simplify this, so this collapses to xe plus py0 times ye over px0. I'm going to do the same thing for the y-intercept, except that this time I'm going to divide the entire thing by py0. So again, collapsing this down into something that's simpler, I have the following equation. So these are the new versions of the real income in terms of good X and good Y, right? So let's talk about the budget constraint dynamics and how the budget constraint is going to move given certain economic disturbances. And what we're going to be focusing on is really just a change in price. So what happens when there's a change in price is that instead of the budget constraint pivoting on the intercepts, it is going to pivot or rotate on the endowment point instead. So let's just say that the price of X is going to fall. Just to use this as a simple example, what you notice is that the denominator here is going to fall, therefore the entire figure is going to increase. So your x-intercept is going to shift to the right, right? And if you look at the y-intercept, the entire figure is going to fall due to a smaller numerator. Therefore, the y-intercept is going to shift down. So as you can see, there's going to be some kind of a rotation that looks something like this. So this is exactly how the budget constraint is going to move given the change in prices. So I forgot to put the price ratio, so this is simply what it looks like. Okay, so it's simple notations, alright? And the next thing you'll be asking is, so where the hell is your indifference curve? Do you like forget about it or something? No, alright, I didn't. So you need to use the indifference curve to actually establish your initial equilibrium, right? So let's identify exactly where we should put our initial equilibrium, because we want different results. Yes, you heard it right. We want different results. From what? Well, we'll talk about it later. Basically, I need you to put your initial equilibrium on the left side of point E. Because if you're going to put it on the right side of point E, then what you'll get is you're going to get the same analysis as if you're using monetary income, which is what we've been going through in the previous video. So you're going to want a different set of results for a very specific reasons, which I will go through later. Okay, just imagine I'm going to push my y-axis to the right, okay? So if I'm going to put my initial equilibrium on the right side of E, which is over there, then what I'm going to get is actually the same results as using monetary income. Because you see, when I use monetary income and the price of X is going to fall, then the same pivoting along the y-axis is going to happen. So it's not interesting, right? So if let's say your initial equilibrium is beside on the left of E, which is there, then what you will get is actually a different result, because now a change in the price of X doesn't cause the budget constraint to rotate along the vertical axis. It is now rotating along the horizontal axis instead. So since we've established that, I'm just going to draw my utility curve and I'm going to establish my initial equilibrium at point A with x0 and y0 to maximize this individual's utility. So the next thing we're going to talk about is when the hell do we use income in kind? So in general, there are three situations where we will want to use income in kind. So what is the first situation? The first situation is when the question is going to ask you, if X is normal good, is it true that the substitution effect and income effect always moves in the same direction? Keyword here would be always. So that is the first scenario. And you can actually prove that it is not always true. So it can be false. Now the next scenario would be the question asking you, if X is a normal good, is the demand curve always downward sloping? So this is another statement that we can prove to be false. And the third scenario, which is the most important scenario, is when the question asks you to use income in kind. Well, this is pretty damn obvious, right? Just look at all the stuff that you learned today. Pretty cool, right? Okay, so now I'm just going to show you some examples of how we can use income in kind to prove certain assumptions wrong. And just like what we discussed previously, please make sure you put your initial equilibrium on the left side of the endowment point. Okay, so we have already established our initial equilibrium. Let's assume that the price of X is going to fall, and we know that the budget constraint is going to rotate along the endowment point, which is going to look something like this. So from here, everything is going to be as per normal. The next thing that we want to do is to identify the Higgson definition of real income, point C, right? So we're going to draw the imaginary budget line such that it is tangent to the indifference curve, and we just label that as point C. And then we're going to draw the vertical line on point C. So as you can see, the new budget line is below the imaginary budget line. This means that real income has fallen, right? So if real income has fallen and I'm moving to the left side of C, that means X is a normal good. And if real income is lower, but I'm buying more, therefore X is an inferior good. So just like that, I've already indicated what is my substitution effect given the Hicksian definition of real income. Next, I'm going to assume point B is going to be here. That makes good X a normal good. So from this step onwards, it's going to be very easy. I can just simply identify where my income effect is going to be. You're going to notice something a little bit odd. I'm sure you remember that we concluded that for a normal good, the income effect and the substitution effect should move in the same direction. But what do you see here? What you see here is that when X is a normal good, your substitution effect and your income effect are actually working in the opposite direction. So you see, this result is different from using the money tree income. So this is what I mean. By using income in kind, you can actually yield different results for different conclusions. So let's check out what the demand curves are going to look like. So given the price of X P naught, this would give me a quantity demanded for X of X naught. So therefore, I have my first point for my demand curve, point A. Now, the price of X is going to fall from Px0 to Px1. So the corresponding quantity demanded will be X1, and there I have another point, point B. So what I do is I'm going to join point A and point B together, and I'm going to have a demand curve for a normal good. So this is downward sloping, it looks normal. But what if point B for X still being a normal good lands somewhere here? So as you can see, if point B were to be there, this means that my income effect is larger than my substitution effect, but X is still a normal good. So I'm going to do the same thing. This time point B for the demand curve is going to be there, and what I notice is actually a upward sloping demand curve. Therefore, using income in kind, I can actually prove that for a normal good, the demand curve can actually be upward sloping, right? So that is how useful income in kind can be. With that, I want to thank you for starting with Quickienomics. Congratulations on finishing Chapter 2.